All right, this is a video lesson for Unit 12, Lesson 2, which is Solving Square Roots, Part 2. So we're going to take what we learned in Lesson 1 about solving by square roots, and we're going to push it a little bit further. So the first thing we're going to do is we're going to go over a problem that showed up in the last lesson's homework, and we're just going to make sure that we understand that problem. So it's a little bit of a review, so you might want to pause the video, try this on your own, and then come back and watch. So in this problem, what I'm going to do is I'm going to try to get x alone. So first I have to get x squared alone. So I subtract 4 from both sides. That gives me negative 2x squared equals 98. And then I'm going to divide both sides by that negative 2 to get that x squared equals negative 49. Now this is an issue for us, and that's why I wanted to talk about this problem. We can't square root a negative. If we tried to square root a negative, it's actually impossible because a square root means what times itself equals the original number. So what times itself equals a negative 49? Well, if you take a positive times a positive, you get back a positive. So if a number is positive and you multiply it by itself, you're going to be getting back a positive. If you have a number that's a negative and you multiply it by itself, then you're taking negative times negative, which negative times negative also equals a positive. So no matter what you do, when you multiply a number by itself, you always get back a positive, but I'm being told I need to get back a negative. That's not possible. So if you're ever in a position where you're trying to square root a negative, it means this problem has no real solutions. Later in your math career, you'll learn about imaginary solutions, which are actually a thing we cover in math, but not here in Algebra 1. So we're just going to say our answer is no real solutions. So you would notice that from the answer key from yesterday's homework, that there were a few problems that had an answer of no real solutions. So this is kind of a summary of what you learned yesterday, but there are going to be some further steps necessary in some of the problems that we're going to do today. So when I'm solving by square roots, how do I know that I need to do it? Well, I know I need to do it if there's nothing in the problem except for squared terms and constants. So you're not going to see something like a 3x. You might see a 3x squared, but you're not going to see just 3x or 5x or 8x or anything that's just an x. You're either going to see constants like 3, or squared terms like x squared, or even 5x squared. But you're only going to see squared terms and constant terms, no x terms. So how do I do it? Well, I get all the squared terms to one side, all the constants to the other, and then I try to get the x squared alone, square root both sides, and sometimes we actually have to finish solving. That's what you didn't see yesterday, and that's what you're going to see in today's problems. So let's get going. Number 1. Well, the squared term is kind of a big squared term now. It's not just x squared or n squared, it's n minus 5 squared. That's all one term. That's the squared term. Once it's alone, we're going to do exactly what we did yesterday, and we're going to square root both sides. So when I square root n minus 5 squared, it actually just gets rid of the square, and it just becomes n minus 5. Just like when you square root x squared, it just becomes x. Well, when you square root n minus 5 squared, it just becomes n minus 5. Now, some of you might need to go to your calculator here to figure out what 25 square rooted, or 225 square rooted is, and the answer is 15. But remember from yesterday's lesson that if we square root something, we need to have both the plus and the minus. So we're going to have n minus 5 equals plus or minus 15. Because it could be positive 15 or it could be negative 15. Now, trying to solve for n minus 5 equals plus or minus 15, we still need to get this n alone. So what we're going to do is we're going to add 5 so this n gets alone. This does not become plus or minus 20. Instead, it becomes positive 5 plus or minus 15. Okay, The 5 isn't wishy-washy, it's just a positive 5, where the 15 is both a plus and a minus 15. So we're going to write it like this. And now, once you get to this step where you have this 5 plus or minus 15, you have to consider both options. What if it's a plus? Well, then n equals 5 plus 15, which is n equals 20. What if it's a minus? Then it's n equals 5 minus 15, or n equals negative 10. Well, both of these can be the solutions. Just like when we had the problem yesterday of something like x squared equaled 9, and we square rooted both sides, and we got x equals plus or minus 3, that meant there were two solutions. 3 and negative 3 were both answers. Well, today, we might have two answers. They just aren't the same number. So 20 and negative 10 are our two solutions for this problem. On to number 2. It's going to be very similar, so you might want to try this one on your own. For number 2, we're going to square root both sides because the squared term is alone. That's going to get rid of the square, so we're going to have x plus 7 equals plus or minus 5, because the square root of 25 is 5. We'll subtract 7 from both sides, and we're going to get x equals, this is a negative 7, so negative 7, and a positive or negative 5. So negative 7 plus or minus 5. That means that x could be negative 7 plus 5, which would be negative 2, or x equals negative 7 minus 5, which would be x equals negative 12. And those are our two answers for that problem. So you see these two problems are very similar to each other. On to 3 and 4. Number 3. This time, my squared term is right here, and it's not alone. It has this 4 next to it. Well, I need to get rid of that 4. So what I'm going to do is I'm going to divide by 4. So I'm going to get x minus 3, still all squared, equals 16. What I get when I divide 64 by 4. So x minus 3 squared equals 16. I'm going to square root both of those sides to get the x minus 3 squared alone. That's going to give me just x minus 3 equals plus or minus 4. Now I'm going to add the 3 to both sides, and I'm going to get x equals 3 plus or minus 4. And finally, I'm going to split this up. It could be x equals 3 plus 4, which is x equals 7. Or it could be x equals 3 minus 4, which could be x equals negative 1, giving us two different answers. So now, what I would again encourage you to do is to go to the next problem and try this on your own while you pause the video, and then you can go back and look to see if you got it correct. So now, taking a look at this next problem, what we're going to do is we are going to get this p plus 8 squared alone. This needs to get alone. So first I need to divide by negative 3. Got to do that to both sides. So we're going to get 16 equals p plus 8 squared. Oh, sorry. Yeah, p plus 8 squared. And then we're going to square root both sides, which is going to make a plus or a minus 4 equals p plus 8. Then we're going to subtract 8 from both sides, and we're going to get negative 8 plus or minus 4 equals p. Then I'll split it up, and we'll get p equals negative 8 plus 4. Oops, no division. P minus 8 plus 4. So that's going to be negative 4. Or p equals negative 8 minus 4, which would be p equals negative 12. And those would be are two solutions to this problem. Last problem. At this point, you should really be feeling comfortable with what we're doing. So one last problem to sure it up. We're going to square root right away. We're going to get x plus 8 equals plus or minus 3. Then we're going to subtract 8 from both sides. Remember, it doesn't become plus or minus negative 5. I have people that want to make that kind of move where you put these together right away. No, it's a negative 8 plus or minus 3. So we're going to have to split it up. We're going to have x equals negative 8 plus 3, which will be x equals negative 5, or x equals negative 8 minus 3, which will be x equals negative 11. Those are our two answers. That's the end of that problem, and that's the end of this video. So here's all of the 5 problems we did today, all very similar to each other, and it all deals with when the square is a little bit more complex, where you actually have a whole expression being squared instead of just one variable.